Hello, everyone. Hopefully, your first day back went really well and you're getting used to your schedule as far as the bells are concerned, and also hopefully your classes are all settled in so you don't have any additional schedule changes that you have to worry about. So, today we're just doing a little bit of a recap on lab and safety equipment. We did get to see a few items yesterday, but not necessarily all the pieces of equipment that we would use. So we're just going to go through a few very quick ones as a refresher here and introduce a few new ones. Okay, so we looked at flasks yesterday and beakers. I mentioned a Florence flask, and those are the ones you normally see in old monster movies. We won't be using those quite as much. And we did take a look at crucibles, mortar and pestles, funnels, wire gauze, tongs, scupulas or spatulas. But it didn't show you like test tube clamps, for example. And the balances that we actually use are electronic balances. They're actually going to be on the sides of the different lab tables. We only have 3 of them that are set up throughout the room. And then your Bunsen burners are going to be underneath with your ring stands. Okay, here's another image of some of the pieces of equipment. We did take a look at rings and ring stands. We'll be using those quite a bit with the Bunsen burners and also funnels. Okay, and I didn't have a chance to show you burettes. We won't be using those till the end of the year when we need more precise measurements of volume. So burettes look a lot like a graduated cylinder, except they generally are more precise. You can measure out to more decimal places, and they tend to be a bit narrower and taller than a graduated cylinder. And they're not freestanding like a graduated cylinder. You actually have to put them in a clamp attached to a ring stand. Okay, so just a quick refresher. Beakers, the numbers on the side are really more of an estimate. There's not very good precision there, so they're great for mixing, pouring because of the slip. They're great for transporting solids. Flasks, on the other hand, we normally will mix in your solid with some water, and then we'll put a rubber stopper on top and then use these for mixing. And again, the milliliter graduations on the side are not very precise, so we tend not to use these for direct measurement. Okay, Florence flask. Here's a better image of one. Like I said, these are your traditional flasks that you'd see in older films. We tend not to use these as much, mainly because of the rounded bottom. They tend to tip over a lot more easily and break, whereas the Erlenmeyer tend to be a bit more stable on the lab table. Okay. Occasionally, we'll have to mix up some specific solutions from scratch, where we might have a solid chemical that we need to dilute down with water to a very particular concentration. So volumetric flasks actually only have one marking, so they're designed to very precisely measure only one particular volume. So in this case, if we were to introduce our solid and then add water all the way up to the mark, we would know that we'd have exactly, in this case, I believe it'd be 100.00 milliliters of solution. So because these have a higher precision, these tend to be a bit more expensive, so we don't have as many of these available. Most of the time, I will be using these to make up your solutions that you'd use for lab activities. Okay, graduated cylinders, you'll have 3 different types in your lab drawer that are marked glassware. You'll have a 100 mil, a 10 milliliter, and either a 50 mil or a 25 mil cylinder. And some will be plastic, some will be glass. And these usually measure out to the nearest tenth. So we won't ever do any mixing in the graduated cylinder. These are only used for measuring liquids, Our electronic balances look a lot like this, except ours are not as beat up, and hopefully we can keep them that way. The one problem with electronic balances, especially with ours, is they can only go out to the nearest tenth as far as a gram measurement. The older hanging pan balances that you would have observed in the images early on, those can go out to hundreds or even thousands, depending on the hanging pan balance. Okay, from time to time we'll be using thermometers for measurement, but in many cases, if at all possible, we'll use vernier temperature sensors with your Chromebooks, and that's mainly because we can get a recording of the temperature changes over time, and then we can use that data to generate graphs, and it's a little bit easier to do interpretations once you have more automatic recorded data sets. But there will be some situations where a thermometer will be more appropriate. So you'll be using both throughout the year. Okay, crucibles we looked at yesterday. Crucibles are designed to withstand really high heat, really high heat amounts from Bunsen burner heating. So if we need to heat up something to a really high temperature to maybe get it to combust or drive off one of the elements that's actually a part of that compound, like oxygen, for example, then we'll use a crucible for that. Okay, if we have to take a solution and remove the water through boiling, we'll probably use an evaporating dish and a watch glass for that. The reason we use a watch glass on top of the evaporating dish is because if you're heating with a Bunsen burner, the liquid inside will tend to boil very quickly, and if you're not careful, you'll get what's called spattering. So in other words, that boiling liquid will fly out at your face, and that's usually quite painful. So we use the watch glass on top so that we can help control the boiling and spattering, so you're not hit with flying bits of chemical solution. And also, because it keeps the wanted chemical inside, we tend not to have any loss in mass. So it helps to reduce your amount of error if you need to do some mass measurement later. Okay, test tubes, we'll be using these from time to time. We don't use them as frequently, mainly because these tend to break first off. And also, most of the time, we're going to be concerned with volume amounts and volume measurements. So because of that, we generally won't use test tubes quite as much. If we're checking for something like a color change or whether or not a gas is produced or not, then we'll probably use test tubes for that initial study. And our test tube racks look a lot like this, except ours tend to be made of metal, so they're more of a wire test tube rack, but they look very similar. Okay, your Bunsen burners look a lot like this. They'll be attached to one of the gas jets at your lab table, and traditionally use welder strikers to ignite the Bunsen burner, but we'll often use matches instead, mainly because if you're not used to using one of these strikers, if you're not used to it and you're new to using a striker, if you turn on the Bunsen burner and let the gas flow and you're trying to use a striker, it's possible you could have a lot of gas come out of here before you actually get enough spark to get the Bunsen burner to light. So if we use matches instead, if I come around with a match, we can light that Bunsen burner right away so we're not flooding the room with gas. Okay, your ring stands, we looked at these yesterday. So here's your ring stand with your iron ring and a test tube clamp. Okay, we also looked at wire gauze and pipe stem triangles yesterday. Sometimes you'll see these referred to as pipe stem triangles, same thing. So we often use the triangles to hold crucibles and evaporating dishes on the ring stand. The wire gauze can be used as well, but in many cases we'll use the wire gauze as a trivet. So if we're removing a crucible or evaporating dish from the ring stand, we'll just set it on the wire gauze so it can rest easily on the lab table without temperature shock. Okay, if we're transporting a solid from a reagent table into a beaker, we'll use either a spatula or scrupula for that. I'll often refer to these as spatulas just because for the longest time that's all I had available. We'll just so you're aware of that. Occasionally we'll use weighing boats if we need to mass out a chemical. So we would use this to remove the solid from the reagent beaker or bottle, and then we put the weighing boat on the electronic balance, zero it out, and then put your solid on here. We'll never ever put solids or any other type of chemical directly on the electronic balance pan. We'll use a weighing boat or a beaker. Otherwise, we could damage the electronic balance. Okay, occasionally, in place of test tubes, we might use something called a microwell plate. And the microwells actually act like little miniature beakers. So we'd mix up your solutions in your microwells and then would often look for something like bubbles or color change or some other indicator of a chemical reaction. Okay, occasionally we'll do chemical changes that generate a suspension, which means we'll often have a layer of liquid solution on top and a layer of solid precipitate on the bottom. And then we'll pour that suspension mixture through a piece of filter paper that's been folded to fit in a funnel. And then that'll allow the solid to be trapped inside the filter paper so that we can mass it. And I will show you eventually how to fold your filter paper so it fits very easily into one of our funnels. We do have glass funnels like this one, but most of ours are plastic. They just tend to be a bit more durable. Okay, mortar and pestles we talked about yesterday. We'll use these for grinding coarse substances. So if we need to dissolve them, we can get a bigger surface area from the ground up solid so it'll dissolve more easily in water. Okay, burettes I mentioned we'd use towards the end of the year. We will often use these for helping to measure out solutions that involve acids and bases. So we will use these when we're carrying out a reaction involving acids and bases. And usually we'll have one burette here with acid and another burette on the other side with base. And then we can very precisely measure the volume of acid and base when we put them into a flask. That way we can get a better feel for exactly how much acid and base we use in our chemical change. Okay, tongs we looked at yesterday. So crucible tongs on the left here, beaker tongs on the right, and they'll be in your metal drawer on your lab table. Forceps. Some of you may have forceps in your lab drawer. So if you have an issue where something gets stuck in a test tube, we'll often use forceps for that. Or if we have to handle small chunks of zinc metal, we might use forceps for that instead of a spatula or scapula. Okay, test tube clamps we already looked at. These attach to your ring stand. If you have a hot test tube or if you have a test tube you have to hold over a Bunsen burner, we'll use a test tube holder for that. The one problem with test tube holders is they have the tendency to allow test tubes to fall. So you have to be careful with the test tube holders because if you actually panic and squeeze the handle, the test tube will fall. So when you squeeze this, the jaws open up and the test tube falls. So if you're using these with a Bunsen burner, you have to remain as calm as possible. Otherwise, you'll have a broken test tube on the lab table. Okay, wash bottles are going to be in your plastic drawer. Like I said, if you ever have chemical that gets stuck on the side of a beaker or flask, we can use distilled water in these to squirt along the sides of the flask or beaker to help rinse out the remaining chemical. These are useful especially when you're filtering. Okay, if you ever have a piece of glassware that breaks or any other piece of equipment, the broken glass will go in a container that looks like this. But before you ever dispose of any broken pieces of equipment, especially broken glass, please let me know right away so that I can take note of it, help you with the broken glass, and get you a replacement piece of glassware or equipment. So the main thing to remember about this situation here is you want to always make sure that you let me know right away that something did break so I can assist you with it and get it replaced for the next group. Okay, we looked at safety shower and eye wash station towards the back of our room yesterday. And again, safety shower is only used if you have large amounts of chemical that get spilt on you, or if you're near the safety shower and a piece of your clothing catches on fire, we get you over here right away and pull this handle to allow the shower to put out the fire or rinse the chemical off you. Eye wash station, again, if you get chemicals in your eyes, we'll get you over here right away. We'll pry open your eyes as best we can and then use the eye wash to get the chemical out of your eyes. But of course, we should never have to use these because you'll be wearing goggles and aprons. Okay, and these, of course, are not to scale. And you got to see goggles and aprons yesterday. Okay, same thing with fire extinguisher and fire blanket. Again, fire extinguishers are putting out surface fires. Fire blankets are used for people mainly that are caught on fire. And that's it. So when you have a chance, go ahead and do the ed puzzle that's related to lab equipment and safety, and that will submit automatically to me. So if you need to review some of these items or remember what the equipment looks like, if you go back to the beginning of this presentation, there are those couple of images that were pulled off Google. So if you need to review, that's a quick way to double check whether or not you know the equipment beforehand, before you attempt that ed puzzle. So anyway, good luck and have a good day.